Here we've got a trig proof to show. So let's look at the left hand side. Cos 2x, that I think is cos squared x minus sine squared x. And that's over cos x plus sine x. Cos squared minus sine squared, well that's cos x minus sine x times cos x plus sine x. And that's all over cos x plus sine x. Cos x plus sine x divided by cos x plus sine x is 1. So this becomes cos x minus sine x, which is the right hand side, and proof complete. Here we have another trig proof, and so cos 2x is, well, 2 cos squared x minus 1, 1 minus 2 sine squared, cos squared minus sine squared. Difficult to know at this point. Let's try cos squared x minus sine squared x. Let's make this a bit neater. There we go. Cos squared x minus sine squared x. And sine 2x, luckily we've only got one formula for that, so that's 2 sine x cos x. Let's multiply out the brackets. So we've got a half cos squared x minus a half sine squared x, and a half of 2 is 1. So this bit is good. The minus sine x cos x, that's the same as that. But this isn't the same. I can see that we should perhaps have chosen 2 cos squared x minus 1 from that. So let's try that again. So I'm just going to start again at this point, because once I've got to this point I can see what I should have done. So the left hand side is a half cos 2x is 2 cos squared x minus 1. Sine 2x is 2 sine x cos x. A half of 2 is 1. A half of 1 is minus a half. And a half of 2 is 1, so it's minus sine x cos x, or cos x sine x. And that equals the right hand side, and so proof complete. So it's perfectly acceptable technique to try one method, see how it gets there, and then when we got to here I see that we should have chosen one of the other 2 formulae at this point here. So that's not correct. This is the final proof.